For these next two examples, we're going to use that process of completing a square that we were practicing the other day, but we're also going to end up with some complex answers. So let's see how this takes, or how this looks. To start, we got to set it equal to 0, because we're finding the zeros using the using completing the square. So we got to set it equal to 0. The first step, just following what we did in the notes previously, we're going to get all the constants on one side and all the variable terms on the other. So we're going to subtract 26 from both sides, giving us x squared plus 10x equals negative 26. Now, what we're going to do next is we're going to add that b over 2 squared to both sides. In this case, our b value is 10, so we have 10, wrote that too big, 10 over 2 squared. Well, 10 over 2 is 5, squared is 25. So we're going to add 25 to both sides of this equation. So we got plus 25 here and plus 25 here. So now we have x squared plus 10x plus 25 equals negative 1. Now, to keep solving there, we're going to factor out that left side. That left side, x squared plus 10x plus 25 factors out to be x plus 5 squared. Again, we're setting this up so that it's nice and easily factorable as one square binomial equals negative 1. To solve for x, we got to get rid of that square, so we're going to take the square root of both sides, and we end up with x plus 5 on the left side. On the right side, the square root of negative 1 we just defined as I. Now, just like we dealt with real numbers, when we took if we do a sidebar here, if we had x squared equals 36, and if we take the square root of both sides here, we end up with x equals positive or negative 6. Now, the same thing applies here with imaginaries. We can have a positive and a negative imaginary number. Now, to keep solving for x here, we got to subtract 5 from both sides, and the final answer, we're going to put it as x equals negative 5 and I are not alike, so we're going to leave it as negative 5 plus or minus I. So you can write it like that as one answer, or if it helps you to think about it as x equals negative 5 plus I and x equals negative 5 minus I, that's another way of describing it. So either version of this answer works. Taking a look at the next one, similar process. We're going to find the zeros. Let's set it equal to 0. Subtract 12 from both sides. We have x squared plus 4x equals negative 12. Now we're going to add that b over 2 squared to both sides. So our b value is 4 divided by 2. 4 divided by 2 is 2. We're going to square that, giving us 4. So we're going to add 4 to both sides. We have x squared plus 4x plus 4 equals negative 12 plus 4 is negative 8. Now, to continue this process, we're going to factor out that left side, which gives us x plus 2 squared. And one thing I didn't highlight in the previous step is that plus 2 we already saw. That was that b over 2. Whatever the b over 2 is, it's x minus, or x plus that, I'm sorry. So it's x plus 2 equals negative 8. Again, just like in the previous step, we're going to solve for x by taking the square root. On the left side, we just end up with x plus 2. On the right side, we have the square root of negative 8. Well, let's break that down to the square root of 8 times the square root of negative 1. Now, just like in the previous problem, we got a plus or minus there. Now, the reason we're breaking it down is so that way we can focus on the imaginary part. So that's just going to be I. The square root of 8, not a nice square number, so let's break it down into the square root of 4 times the square root of 2. And this is still positive or negative. So we have x plus 2 equals plus or minus square root of 4 times the square root of 2 times I. Now, when we clear that up, we get x plus 2 equals plus or minus square root of 4 is 2 times the square root of 2 times I. I'm going to reorganize that in a little bit. Now, to get x all by itself, we're going to subtract 2 from both sides. And now this is one big old term. It's an imaginary term. We cannot combine the imaginaries with real parts. So we're going to leave it as x equals negative 2 plus or minus, and then I'm going to write it as 2 times I times the square root of 2, which is the same as saying 2 times the square root of 2 times I. So again, just like in the previous problem, if it helps you to think about it as two separate answers, I'm going to say or, you could write it as x equals negative 2 plus 2I times the square root of 2, or x equals negative 2 minus 2I square root of 2. Either way works.